My session is about temporary tables and table variables, the complete guide, so-called. We'll talk about what's each one, what are the differences, the main differences, and when to use what. That's the big question. Um, my name is Glantser. I'm a data platform MVP. I work with the data platform of Microsoft for the past 25 years or so. I'm the CEO of Madeira Data Solutions. We do lots of project services for customers around the Microsoft data platform. We have a podcast, SQL Server Radio, as you can see here. I write a lot of blogs, I speak on lots of different events. That's about me. And let's talk about the topic, temporary tables and table variables. These are two different types of using temporary structures, temporary tables to hold data. There are many, many use cases for that, and I want to talk about the differences. I'm sure that most of you know most of the differences maybe, but I'm sure that I can share some new stuff that maybe you weren't aware of. So first of all, let's talk about storage. Both of them, temporary table, the one with the number sign, and table variable, the one with the @ sign, both of them are stored in TempDB in the exact same way. Some people think that table variables are only in memory or something like that. That's not true. Both of them are in TempDB. They use the same allocation structures, the same methods to create, to handle them inside TempDB. So it's just the same. But the scope is different. For temporary tables, the scope of the table is the session. As soon as my session is closed, the temporary table goes away. With table variables, as soon as the batch is completed, the table variable goes away. A batch is a set of statements that I send as one unit to SQL Server. One example is a store procedure, for example. So as soon as the store procedure is done, no more table variable. If you try to access the table variable outside of the store procedure, you will get an error that it doesn't exist. With a temporary table, it exists as long as the session exists. Okay? For that reason, I think some people think that table variables are not stored in TempDB, because if you go and check in TempDB, in most cases, you will not see the table variable because your batch is already done. It's very, very quick. But with the temporary table, it's still there as long as your session is active. Can we use constraints? I'm talking about primary keys, foreign keys, check constraints, stuff like that with each one of them. The answer is yes. With temporary tables, we can use constraints just like with regular tables because we have DDL statements, create, alter, and drop. So we can do alter table for a temporary table, add a primary key, or check constraints, or whatever. With a table variable, it's a bit tricky. It's different because we can't use DDL statements. We can only use the declare statements to declare a new table variable, and that's it. We can't make any changes to the schema of a table variable once it's declared. But what we can do, as part of the declare statement, we can add constraints and other stuff into the table variable. So it's possible, but in a different way. Not very common, but if you need to use, we'll show you an example later when we want to use a primary key inside a table variable, then it's possible. I will show you how. What about indexes? The exact same thing. Okay, we can use DDL statements to create indexes, change indexes, remove indexes for temporary table. We can use indexes with table variables, but only during the declare. Okay, when we declare a table variable, we can also add indexes to that variable. Now that's a big difference because the best practice in most cases is first to create the temporary table when it's empty, create it as a heap without any indexes, then load your data. The load will be faster because you don't need to maintain any indexes, and only then create the indexes after the data is in the table, and then the indexes will be with zero fragmentation. With a table variable, unfortunately, we can't do that because you can only create the indexes when the table is declared, and then you need to load data while the indexes are already there, and you get fragmentation. The load is slower, and so on and so on. So that's a big difference there. The main difference between the two is statistics. This is the big deal here. Okay, so we have statistics for temporary tables. We don't have statistics for table variables. Not at all. No statistics, no histograms, nothing. So SQL Server is blind. SQL Server, or specifically the optimizer, or even the cardinality estimator, doesn't know what happens inside the table variable. What is the distribution of the data in each one of the columns? The same way that it knows about temporary tables. Okay, and this is a big deal, and I will show you some examples later in the demo. What about recompilations? It goes with statistics. It's when you have statistics, and statistics get updated once in a while, then each time statistics is updated, there is also a recompile. The plan, all the plans that rely on the previous statistics now needs to get recompiled. So you get recompilations. Recompilations make some overhead. There is an impact on CPU resources and so on when there are recompilations. If there are many, many recompilations all the time, it might have a big impact. On the other hand, recompilations are good because we want to get a better plan as soon as we have better statistics. With temporary tables, we have statistics updates, we have recompilations. With table variables, we don't have each one of them. So with no statistics, also no recompilations. I'll talk about that later in demo. Transaction log footprint in TempDB. With each DML statement that we run, SQL Server also needs to write everything in the transaction log. It has quite a big impact. The same happens in TempDB. Whenever you insert, update data in temporary tables or table variables, SQL Server needs to write in the transaction log. But there is a difference here. With temporary tables, we have transactional consistency. This means that if you insert data into a temporary table inside a transaction, and then you roll back the transaction, you also roll back the insertion of the data into the temporary table. For that reason, SQL Server needs to maintain all the data for recovery purposes in the TempDB in the transaction log of TempDB. But with table variables, you don't get transactional consistency. If you insert data into a table variable inside a transaction, then you roll back the transaction, nothing happens to the table variable. As long as it's still the same batch, the table variable still exists with the same data. It doesn't roll back. And since it doesn't need to roll back, it also doesn't need to write everything for the sake of rollback in the transaction log of TempDB. So you get minimal logging compared to temporary table with table variables. Sometimes this can make a difference. What happens if you want to use table parameters, table valued parameters with store procedure or functions? In that case, you don't have a choice. You can only pass a table as a parameter using a table variable, not a temporary table. And then within the function of the store procedure, you have access to that table variable with all the limitations and the differences that we talked about earlier. And I will show you what you can do about it if you don't want to use a table variable inside a function or a store procedure, again, later in the demo. Last thing, I think it's the last one, parallelism. There is a difference there. With a temporary table, you can get full parallelism. The optimizer has the flexibility to decide whether to use a parallel plan or a serial plan, and also for each one of the operators, which one is better. With a table variable, you can still get a parallel plan, but the section that inserts data or updates data inside the table variable always has to be serial. If you need to load a lot of data into a table variable, it will always be serial using a single thread. That can be a big bottleneck. Okay, so another thing to consider. And of course, the big question is when to use what. And for that, we have a demo. So let me open the demo. I hope you can see my screen. Okay. Let me run the database setup. Should be quick. And then we can start.
Hello.
So, yeah.
Could you please increase the font of the Management Studio?
Sure.
And maybe hide the top bar with shortcut Shift Alt Enter.
Is that okay?
Thank you.
Excellent. Okay, so I'm going to use set statistics IO on and also the actual execution plan. See what's happening. And another thing I need to do. Let me start this one over. And this one. This one. I'm going to use an extended events to track recompiles. Okay, and we are here. Good. So, first thing I want to do, I'm going to create a store procedure which accepts one parameter, number of customers. And what it does, I'm going to declare a table variable first inside the store procedure called selected customers with customer ID. I'm going to insert into my table variable a random list of customers. I have a customers table. It has around, I think, 1 million rows, something like that. I'm going to choose the top number of customers, which is my parameter. This will allow me to execute a store procedure with a different number of rows each time and to see what happens to the table variable. Okay, so I'm going to insert a random customer IDs each time, and the number of rows will be the parameter. And then, once I have the list of customers in my table variable, I'm going to do this one. This is the main select statements we're going to track to see what happens. This select statements takes the data from the table variable and uses auto reply to fetch the top 3 orders, another table, for that customer ID, ordered by daytime descending. Okay, so the last 3 orders for each customer. Essentially, that's what I'm doing with this stored procedure. I get a number of rows, I get a random list of customers using that number of rows, and then for each customer in the list, I want to fetch the last 3 orders. Okay, this is my stored procedure. Let's create it. And let's test it with 1,000 rows, 1,000 customers. Now, it's going to take a while. And I have to say something important here. I'm using SQL Server 2019. There is a feature related to table variables in SQL Server 19, a new feature called deferred table variable compilation. I disabled it on purpose. So if you're asking yourself what's going on, it should be fast. It's not fast because I disabled it. I want to show you what happens before SQL Server 2019 first and what's new in SQL Server 2019. This is one of the things I want to show you here. So now I'm using 2019, but without the new feature because it's disabled. Okay. It's going to take, I think, about 1 minute. The big problem here, the reason it takes so much time, because we're only talking about 1,000 rows. Okay, so this should be very, very quick to insert 1,000 rows into the table variable. And then for each of those 1,000 rows, I want to take the select top 3 from the orders table. What's the big deal? Okay, the big deal is that because we don't have statistics for a table variable, SQL Server doesn't know the number of rows in a table variable. Okay, it doesn't know what happens here, essentially when I do the select, when it needs to select for the table variable, how many rows are in the table variable. And since it doesn't know, it has to decide something. It always estimates 1 row, single row in the table variable. Whether it's 2 rows or 1 million rows, it will always estimate just 1 row. And what happens, wow, that takes a lot of time. I will show you that because it estimates only 1 row, it will use a nested loops join operator, okay, to join between the table variable and the sales orders, which are using the auto reply, because it thinks it's only going to use 1 iteration. Essentially, it's going to use 1,000 iteration, and that's the big deal here. While it's running, it should be faster. I don't want to waste time. So I'm going to go ahead and talk about what's next. Okay, so now we're running this one, 1,000. The next step will be to create the exact same store procedure, but this time with a temporary table. Okay, so it's the same store procedure, only instead of declare, I'm going to use create table with a number sign, insert data into the temporary table, and then use the temporary table. That's the only difference. It is done. Okay, so we get almost 3,000 rows because we need the 3 last orders for each one, and some customers has less than 3 orders altogether. Here is the execution plan. The top execution plan is for the insert into the table variable, and the lower one, this one, okay, we do a table scan from a table variable, and notice that the optimizer estimates only 1 row, and the actual number of rows is 1,000. And this is the big deal here. This is the big problem because of the lack of statistics. Because the optimizer estimated during compile time only 1 row, it uses the nested loops. And now we do 1,000 times, it's going to do a clustered index scan on the orders table. Of course, this is because we don't have a proper index here on the customer ID. We'll add that index later. We also get this missing index recommendation. Okay, so the optimizer says, hey, you should create a non-clustered index on the sales order table on the customer ID column. We will do that later. Okay, for now, we'll continue without it. So we essentially had to scan the entire orders table 1,000 times, which results, here as you can see, the orders table 1,000 scan count results in this number of logical reads. This is a lot, only to bring 3,000 rows. Okay, so that's the big problem here. Now, what happens when we create the second version of the store procedure with a temporary table? And we're going to test it also with 1,000 rows. Instead of, how much was it, 2 minutes? Something like that. Now it's going to take 8 seconds. Okay, that's a big difference. And again, the reason is that now SQL Server knows exactly how many rows are in the table because it has statistics for a temporary table. It's not exactly because of statistics. It's because a feature of temporary tables called deferred compilation. and I will show you that later. We'll create an event session to track recompiles. I will show you the reason for the recompile. Okay. And how does SQL Server now handles the information that it has, that there are 1,000 rows in the temporary table? It still uses the nested loops, as you can see. So you might say, hey, what's the big deal? What's the difference? We have nested loops. We still need to do the class.index scan 1,000 times. How come it's different? How come it's only 8 seconds? And the reason is the index pool here. Now, because SQL Server knows there are 1,000 rows, and it's going to be 1,000 iterations, it says, okay, I'm not going to do a scan 1,000 times on the orders table. I'm going to do this one only once, only the first iteration. It's going to scan the entire sales orders table. Then it's going to create an index. This is an index pool. It's just like a regular non-clustered index on the customer ID, the one it's recommended for us to create in the previous plan, the one that we should have created. And it says, okay, I'm going to create this index on the fly. In each execution of this query, as part of the execution plan, I'm going to scan the orders table, create an index on the customer ID, populate it, sort the entire data, populate the index. This is what the egress pool means. The egress pool says, I need to consume the entire sales orders table, the entire input, populate the entire non-clustered index, and only then I will start outputting rows. Okay, so essentially we're going to have a complete index on customer ID for that plan, which this what takes most of the time. Okay, the reason it takes 8 seconds and not 0 seconds is because it needed to build this index. And it's going to do it every time, which is crazy. And now, in the next 999 iterations, it's only going to do an index seek against this index pool instead of going all the way to the scan. So that's how the plan is handled now. Notice that now we don't have a missing index recommendation, because as soon as we have an index pool in the plan, the optimizer doesn't provide that recommendation. For me, I think it's a bug, if you ask me, because it needs to still recommend this index. We still need to create that index. It will be a lot better than having SQL Server created each time again and again. Okay, but we don't get this recommendation now. Anyway, let's start the event session. So I'm going to create an extend event session called track recompiles. I'm going to use the event SQL statement recompile. So everyone, a specific statement within the stop procedure gets recompiled. We're going to get an event with the recompile reason. That's the important thing I want to show you. And I'm going to write into a file. Let's create the event session. And let's start it. And I have here a query with some X query to retrieve data from the file. Okay, so currently we have nothing. And let's go back here. Let's clean the plan cache. So we start from scratch. And first, let's run the table variable version, this time with 100 rows, because we don't want to wait 2 minutes. So with 100 customers, it takes should be around 10 seconds, something like that. Okay, 11 seconds. And first of all, let's go here. Let's see what happens. Okay, so we don't have any recompiles or compiles for that matter. Okay, because there are no statistics, no need to compile anything at the statement level. And if we look at the plan, so again, we get an estimation of 1, and we have to do this scan 100 times, just like before. Okay, but no recompiles. If we run the temporary table version with 100 rows, as soon as it finishes, we look at the recompiles. So now we get 2 recompiles, and the recompile cause is deferred compile. This is a mechanism used by SQL Server for temporary tables. Since the temporary table is only going to be created and populated inside the stop procedure at runtime, then during compile time, SQL Server still doesn't know how many rows are going to be there. So there's no point in generating a plan at compile time at the point where it doesn't know how many rows are there. So it defers the compilation of all the statements that access the temporary table to runtime. And only at runtime, as soon as SQL Server gets to a specific statement, like these two, okay, each one of those statements access the temporary table. This one inserts data into the temporary table, and this one selects data from the temporary table. But both of them access the temporary table. So at runtime, they get compiled or recompiled, and then the plan takes into account the actual number of rows in a table. This is called deferred compile. It's a feature that exists only for temporary tables before SQL Server 2019. That's the new feature in 2019, which I will show you later. So if we go back here, thanks to this deferred compilation, now as you can see, SQL Server knows exactly how many rows. We have 100 rows in the table, but yeah, no but. Okay, that's fine for this. Let's do this 5 more times. Okay, so I'm going to execute the same stop procedure with a temporary table with the same value, the same number of rows in a temporary table 5 more times. And the question is whether is it going to recompile the temporary table again and again for each execution, because the temporary table in each execution gets created and populated from scratch. Okay, so it needs to get recompiled each time. And the good news is that it's not going to do that. I will show you that there are no recompiles whatsoever. As long as the number of rows in the temporary table gets more or less the same, then there is no reason to recompile. SQL Server uses a caching mechanism. It knows what was the last number of rows, the cardinality value in the temporary table. As long as it doesn't change, it doesn't need to recompile. So if we go here, no new recompilations. And of course, if we go here, you can see that all the plans are the same with 100 rows. What happens if I use a slightly different number, 101? Okay, it's not the same number, but it's not very much different. In this case, first of all, no recompile. If you look at the plan, you can see that the estimated number of rows is still 100. The actual is 101. Okay, so it reuses the same plan from before, no recompile, but it's good enough. Okay, that's a good thing. No need to recompile because it's almost the same number. But if you use a completely different number, like 1,000, now that's something else. SQL Server says, okay, this is a lot different from the last value I used. There is a statistics change here. It will going to trigger a recompile using the statistics change recompile codes. Okay, it triggers a recompile, and now, of course, if we look at the plan, we have a new plan using 1,000 rows as the estimated. Okay, which is great. So each time the number of rows in the temporary table varies a lot from the last time, it will trigger a recompile. Let's go on. Now, let me enable the new feature in SQL Server 2019 called deferred compilation TV. Okay, which is enabled by default, by the way. Whenever you create a new database in SQL Server 2019 or Azure SQL for that matter, okay, it is enabled by default. I disabled it on purpose for the sake of this demo. But if you migrate to SQL Server 2019, for example, you get this enabled by default. And what it does, if I now use the 100 rows with the table variable version, it uses the same mechanism for statistics change with table variables. Now, we still don't have statistics for table variables, so SQL Server doesn't have a clue about the distribution of the data, but it does track the cardinality, the total number of rows in the table variable using this new feature. And whenever it changes, again, a lot, okay, it will trigger a recompile. So now, first of all, let's look at the compiles. Now we get the same as we got here, the 2 deferred compile with the temporary table. Now we get 2 deferred compile with the table variable. Okay, again, this is new in SQL Server 2019. And for that reason, we now have a good estimation of 100 rows. But if you look here, there is something else that is interesting. We have a sort and a table spool, 2 new operators we didn't see before. And why do we have them? Since we don't have statistics with a table variable, as you can see, SQL Server knows there are 100 rows, but it doesn't know how those 100 rows are distributed. Okay, we have a list of customer ID, 100 customer IDs. Is it unique? Is it one single customer ID 100 times? Is it something else? SQL Server doesn't have a clue. It needs to estimate something about the distribution. And what SQL Server does in this case, it always estimates the square root. Meaning, if we have 100 rows, the square root is 10. So it assumes that there are 10 unique values. In our case, 10 distinct customer IDs. For each customer ID, there are 10 rows. Okay? If we had, for example, 400, it would use the value 20 for that matter, and so on and so on. Okay, so in this case, it says I assume there are 10, and SQL Server doesn't want to do this scan so many times, so it uses a table spool. The table spool takes the last 3 orders for each customer ID and store them in a temporary table in memory. That's the reason We have a table spool here. Why? Because SQL Server says the next time I'm going to use the same customer ID because it assumes that the customer ID has 10 rows in the table variable. The next time you use the same customer ID, I don't need to go all the way here. I already have the 3 last orders for that customer. I've already calculated them. Okay? And in order to make it even more efficient, it adds a sort operator. So it sorts the data by customer ID. And then it says, okay, the first customer ID, I'm going to get 10 rows, one after the other, with the same customer ID value. That's what it thinks is going to happen. And then I'm going to reuse the table spool very efficiently. Then the 11th row is going to be a different customer ID. I will go all the way here to get the last 3 orders for that customer. And again, then the next 9 rows will be for the same customer ID, and so on and so on. So it adds the sort operator and the table spool based on the assumption that we have 10 distinct customer IDs. Of course, this is wrong because we have unique customer IDs in the table variable. But SQL Server doesn't know that because it doesn't have statistics for the table variable. What we can do, for example, we can add a primary key. If we add a primary key constraint to the declaration of the table variable, because we know that the customer IDs are unique, this will help the optimizer because in this case, even without having statistics, since there is a primary key, of course, there are unique customer IDs. So let's add the primary key. And that's, I think, a good example to show you that sometimes constraints also act as performance boosters for the optimizer, not just being constraints, because the metadata, the information that they have, sometimes can be goals for the optimizer. So let's do that. Let's use the same table variable store procedure with 100 rows. And now we will see in the plan that we don't have the sort, we don't have the table spool anymore. Okay, and the numbers will be a bit different. Okay, so no more sort, no more table spool. But now, since SQL Server said, okay, now we have 100 different customers, this means I will have to go all the way and do 100 clustered index scans. So no, now it adds the index spool, eager spool, just like before. Okay, which is better in this case. Okay. What happened if now I use 1,000 rows? A completely different number, just like we did before with the temporary table. We still get the estimation of 100. Okay? And the reason is that we don't get, okay, this was the deferred compile from before. We don't get now statistics change recompile, okay, because still there are no statistics. The only thing we get with the new feature in SQL Server 19 is the deferred compile in the first execution. The first time we need to generate a plan, there will be deferred compile, but that's it. Now, if you continue to run the same store procedure with different number of rows, you don't have recompiles anymore. You get stuck with the first execution. Now, it's time to create the non-clustered index on the customer ID in the sales orders table. And now things are different. Let's use first the table variable version with 1,000. And I want to show you that we have now a new reason, schema change. Since we changed something about the schema, we created a new index. So there is a new reason to recompile. Okay? SQL Server now, again, at runtime, when it gets to this select statement, it says, oh, there's a new index. Let's recompile, create a new plan to use that new index, potentially. And if we look at the plan, then yes, now we have an index seek and the key lookup. Okay? And SQL Server says, okay, now because it was recompiled, it knows there are 1,000 rows. It knows it's going to do this 1,000 times, and so on and so on. But that's the best plan in this case. If we try to run it with 10,000 rows, first with a table variable, okay? So there is no recompile. We still estimate 1,000. And now there are many, many index seeks and key lookups. So we get a lot of I/O here, because SQL Server doesn't know that there are 10,000 rows. If we go with a temporary table version with 10,000 rows, now it's even worse. I want to show you in this case, the optimizer got it wrong. It takes more time. Let's look at the plan. So now we have a parallel plan. SQL Server knows there are 10,000 rows. Okay? And it says, in this case, so many rows, and there are so many key lookups I'm going to have to do. And in this case, I'm going to do a scan and an eager spool, like we did before. Okay, SQL Server says it's better to use this. And in this case, it's going to create an index spool with all the columns that it needs. Unlike the index that we created, in which we don't have all the columns we needed, and then we needed to do key lookups. In this case, we don't have key lookups. Okay, so that's why the optimizer decided to do that. Of course, we can help the optimizer by dropping the index and creating another index with the included columns that were previously missing. So now, let's try again the table variable version. So we get an index seek without the key lookup. And in this case, even with a temporary table version, we get the exact same plan. Okay, because now we don't have to do the key lookup. It's better to do 10,000 index seeks than to do a clustered index scan and an index pool, egress pool. That's great. Another option is to use option recompile. So I'm going to go back to the table variable option, and I'm going to add option recompile to the select statement. It's part of the statement. What option recompile does, it tells the optimizer, actually the query processor, to recompile this specific statement at runtime each and every time, in each execution. The important thing here, it happens at runtime. And when SQL Server needs to recompile something at runtime, it has a lot more information than when it needs to recompile something at compile time. Information like, for example, the number of rows in the table variable. SQL Server always knows the number of rows, the total number of rows. Again, still no statistics, but the total number of rows in the table variable at runtime, and it's going to happen each time. So this is a great feature, a great thing to add option recompile. On the other hand, there is a big risk. If you're going to run this stop procedure many, many times concurrently, like 10 times per second or whatever, then it's going to recompile each time. You're going to have lots of recompilations all the time. This can really degrade performance and get your CPU to 100% all the time. It's really risky. Okay. On the other hand, if this stop procedure runs a report that runs only once in a while, even once every few minutes, okay, it's like nothing, then I will always prefer to use option recompile, because there are many advantages to doing that, again, because of the nature of doing it at runtime. So let me show you how it behaves. And by the way, even if I use a temporary table, not just a table variable, that has statistics, if I can afford it, then I will still use a temporary table with option recompile, okay, because I can potentially get a better execution plan. So now, with option recompile, with 1,000 rows, first let me show you that we get a new reason, option recompile requested. And the plan is going to use the right number, 1,000, even with the table variable. With 10,000 rows, of course, we get another option recompile requested. And we get, again, the right plan with 10,000 rows, a different plan in this case. Okay, so every execution, you'll get the exact number that you need. Let me show you what happens when we want to use a table type, a table parameter. Okay, so now I have a new table type, selected customers. Just like before, I have a new procedure with the table parameter that uses the table parameter this way. And now instead of creating the temporary table inside the stop procedure and populating it, we're going to populate the temporary table, or the table variable in this case, outside of the stop procedure, and then pass it as a parameter to the stop procedure. So now the stop procedure only includes the select statement, okay, using the table variable, which is our parameter in this case. So let's create that. And here is the code to run the stop procedure. I declare a table variable out of the table type. I populate it just like before with the random number of customers, and then I'm going to execute it and pass it as a parameter. So in this case, thanks to parameter sniffing, SQL Server in the first execution, when it needs to compile the stop procedure, it knows the number of rows of the table valued parameter, which in our case is 1,000, and uses the correct plan. Okay, it's not a recompile; it's based on parameter sniffing. In this case, if we run the same stop procedure again with a different table variable, a different parameter, with 10,000 rows in this case, so there is no reason to recompile with the table variable. No statistics changed, no parameter sniffing. Again, there is a plan already. So we get a wrong estimation of 1,000 while we actually have 10,000. Okay. And again, because we don't have statistics, we still have the same problem with the sort and the table spool operators just like before. Because SQL Server, we don't have a primary key. in this case. I didn't put the primary key in the definition of the table type. Okay, of course we could do that. Sorry. Okay, there are several options. Okay, if this is not good enough, we are using a table valued parameter, and the performance is not good enough. There are several options to solve this problem. One of them is to create a temporary table inside the stop procedure. Then I will copy all the contents of the parameter to the temporary table, and then I'm going to use the temporary table in my query. In some cases, it makes sense. Okay, in some cases it doesn't, because the overhead of doing that might overcome the benefit of using it in the query. But in other cases, it might be different. So you need to test. The more you use the temporary table in different queries, it makes more sense to only once pass the data into the temporary tables and use it. But of course, it depends on your case. But let's just see how it works. So now I'm going to test it again with 1,000 rows. And if we look at the plan, then this one here, this inserts outside of the stop procedure, inserts data in the parameter, the table variable. This one copies the content of the table variable to the temporary table. And this one uses the temporary table, of course, with the correct number of rows, because we have deferred compilation for temporary tables. And we also have statistics. So everything is great. But of course, we pay the price for doing this part. If we use 10,000 rows, then of course, in this case, thanks to statistics change, because we're using a temporary table, SQL Server knows there are 10,000 rows. It's going to recompile, generate a new plan. Another option is to use option recompile, just like before. I'm using, again, a table parameter, and I'm just going to add option recompile to the select statement. Again, if I can afford it, because we only execute this stop procedure once in a while, then that's going to work great. And again, 1,000 rows with the correct estimation, 10,000 rows, we get the correct estimation again, and so on and so on. Okay. Last thing I want to show you, and then I'm going to summarize everything. We can use trace flag 2453. What this trace flag does, it makes a table variable behaves in a similar way to a temporary table. It still doesn't have statistics, but it tracks the number of rows. And when they change, it's going to do a statistics change, recompile, just like with temporary tables. So I'm going to enable this trace flag and then disable it at the end of the stop procedure. And I'm going to execute, again, our table parameter stop procedure with 1,000 rows. And we get the correct estimation. And then with 10,000 rows, oops, and we still get the correct estimation thanks to this trace flag. Okay, so we don't have to pay the price to copy the data in a temporary table. We don't have to pay the price of recompiling each time. SQL Server will use the same mechanism to trigger a statistics change only when it needs to recompile. So that's a great feature using this trace flag. Another option I'm not going to show you because we don't have much time is a hybrid approach. Sometimes neither of the options is good enough. Okay, sometimes the number of rows in the table varies a lot, and in some cases a table variable is better, in some cases a temporary table is better. So what we can do is come up with some hybrid approach. For example, if the number of customers is less than 10,000, use the code with the table variable. Otherwise, if it's more than 10,000, use the temporary table. You can also say if it's more than this number of rows, which is rare, then use option recompile. And it's only going to happen once in a while. Okay, so you can use this kind of hybrid approach to solve your problem. Sometimes this will work. I'm going to go back to the presentation to talk about the bottom line. Okay, so I got 3 minutes left. Let's summarize. When to use what? That's the question. So, first of all, if the batch, in our case the stop procedure, is executed only once in a while, and again, once in a while could be even, it depends on of course, the workload, the server resources, and so on. But sometimes once in a while can even be a few times per second. That can be once in a while in your case. You need to test. If it's once in a while, use a temporary table and option recompile. That's the best solution. Because with a temporary table, you get statistics. With option recompile, you get the best plan each time. Okay, and you need to test it to see if you can afford it in terms of recompilation, CPU overhead, and so on. But that's the best option if you can afford it. Otherwise, if the batch is executed many times per second, then you need to test if the number of rows in your table is relatively fixed. And this is, depending on your use case, sometimes you use the same number of rows each time, or a very similar number of rows, sometimes it varies a lot. If it's relatively fixed, use a temporary table, because you're not going to suffer from any memory compilations in this case. And you're still going to get statistics with all the benefits that comes with it. If the number of rows varies a lot, it varies all the time, then you need to test performance with a temporary table. Use a temporary table, run your workload many, many times concurrently, and test how many recompilations you get, what happens to the CPU, and so on and so on, and see if performance is acceptable with a temporary table. If it's acceptable with a temporary table, then, of course, use a temporary table. If it's not acceptable, you still need to test whether it's acceptable with a table variable. Okay, it doesn't mean that with a table variable it will be better. Maybe it will be worse. If it's acceptable with a table variable, then go ahead and use a table variable. And if you ask me, that's the only reason, the only use case where you should use a table variable. When you test it and you see that with a temporary table, you just don't have a choice. You just have too many recompilations. That's a very, very rare case. Okay, but it can happen, of course. If performance is not accepted either way, then of course try a hybrid solution. Okay, I talked about that before. And the last thing is when you use a table variable parameter, then either copy the data, well, of course, you can do nothing. If it's good enough, great. If it's not good enough, you can either copy the data into a temporary table, or you can use option recompile if you can afford it, or use phrase flag 2453 to make it behave like a temporary table without statistics, okay, which is a very good way to handle it, I think. That's it. Wow, that was fast. Thank you very much. If there are any questions, this is a good time for that, I guess.
Do we have any questions? Someone?
I can hear you.
Could you please share your contacts, please? Again, contact details.
Is it me? No, my configuration is okay, but I can't hear you.
Could you please share your... Oh. Could you please share your contact details, please, again?
Yeah, sure. Let me... Here it is.
Okay. That's great. Thank you very much.
Thank you.